China versus USA, how a $10 billion robotics challenge could redefine global technological leadership. Overview. The $10 billion robotics challenge between China and the USA represents a critical juncture in the ongoing competition for technological supremacy between these two global powers. Set against the backdrop of a rapidly evolving technological landscape, this initiative aims to spur advancements in robotics that could have far-reaching implications across various industries including manufacturing, healthcare, and military applications. The technological arms race. The challenge epitomizes the intensifying technological arms race between the USA and China. Both nations are heavily investing in artificial intelligence (AI) and robotics as they aim to secure their positions in what is often referred to as the next industrial revolution. This rivalry not only encompasses economic interests but also national security concerns, with each country striving to outpace the other in technological innovation. Government support and investment strategies. The governmental approach to fostering robotics development starkly contrasts between the two nations. The U.S. government has committed significant funding to stimulate innovation in robotics, primarily leveraging the strengths of the private sector. This public-private partnership model encourages collaboration among tech companies and universities aiming to harness diverse expertise and resources. In contrast, China employs a more centralized state-backed strategy. The Chinese government has established extensive initiatives designed to propel AI technologies and robotics development. This approach often results in rapid implementation of projects driven by the state's ability to mobilize resources and direct funding towards specific goals. However, it may come at the cost of individual creativity and innovation typically seen in a more decentralized system. Focus areas and industry applications. The robotics challenge is not just about funding, it is also about the direction of research and development. U.S. firms are increasingly focusing on collaborative robots, cobots designed to work alongside human operators in manufacturing settings. This reflects a broader emphasis on enhancing human-robot collaboration to improve productivity and workplace safety. Conversely, Chinese companies are making strides in developing autonomous robots, particularly for logistics and manufacturing applications. This focus on automation demonstrates China's priority in streamlining processes and reducing labor costs, aligning with its broader economic goals. Timeline of key events. Early 2000s, both countries ramp up investments in technology, particularly AI and robotics, laying the groundwork for future competition. 2010s, the U.S. experiences a surge in venture capital funding for robotics startups, while China launches its Made in China 2025 initiative aiming to dominate advanced manufacturing technologies including robotics. 2020, the U.S. government announces the $10 billion robotics challenge aiming to foster innovation and attract top talent in robotics. 2021, various U.S. tech firms begin forming strategic alliances to participate in the challenge, while Chinese companies accelerate their R&D efforts, benefiting from robust state support. 2022, as both nations intensify their efforts, the implications of the technological arms race begin to crystallize, highlighting potential shifts in global supply chains and economic power dynamics. Implications for global leadership. The outcome of the robotics challenge holds significant implications for global technological leadership. Both the U.S. and China perceive robotics as a vital area for future economic growth and national security. The competition is characterized by substantial government investment, with each nation adopting distinct strategies to stimulate innovation. The results of this challenge may redefine not only the technological landscape but also the economic power dynamics on a global scale. As each country navigates its unique approach, the implications will be felt well beyond the robotics sector, potentially influencing everything from trade policies to international relations. Conclusion. In conclusion, the $10 billion robotics challenge between the USA and China serves as a pivotal moment in the ongoing rivalry for technological supremacy. With both nations poised to make significant advancements in robotics, the outcomes of this challenge will likely resonate throughout the global economy and influence the future trajectory of technological development. As the competition unfolds, the world watches closely, aware that the stakes are high and the implications far-reaching. The ongoing $10 billion robotics challenge between China and the USA reveals several counterintuitive insights regarding technological competition and leadership between these two nations. Here are the key points of counterintuitive information gleaned from the context of this challenge. 1. Perception of innovation sources. While it is commonly believed that innovation comes primarily from private sector initiatives, the challenge demonstrates that state-led initiatives, as seen in China, are equally capable of fostering rapid advancements in technology. China's centralized approach, which might ostensibly seem less innovative due to its top-down nature, can lead to quicker implementation of robotics technologies, potentially outpacing U.S. private sector innovation. This contrasts with the assumption that private sector-led innovation is inherently superior. 2. Public-private partnerships versus state control. The narrative surrounding the U.S. approach emphasizes collaboration and partnership, presenting it as more progressive and conducive to creativity. However, the reality may reflect a slower pace of innovation than the state-driven model in China, which can mobilize resources and direct efforts toward specific goals more effectively. This challenges the belief that decentralized systems are always more innovative. 3. Divergent priorities and outcomes. The U.S. focus on collaborative robots for human-robot interaction versus China's emphasis on fully autonomous robots might suggest a philosophical divide. Yet the counterintuitive takeaway is that while the U.S. approach fosters human-centric designs that could enhance workplace safety and productivity, China's push for automation could lead to more efficient and cost-effective manufacturing processes. Thus, each strategy, rather than being categorically better or worse, serves different economic and social needs that could redefine competitive advantage in unforeseen ways. For implications for global supply chains, the assumption that U.S. technological advancements would naturally lead to dominance in global supply chains may not hold true, as China's advancements in robotics could enable it to streamline logistics and manufacturing at scale. This could shift the balance of power in global supply chains, where efficiency and cost-effectiveness become more critical than innovation alone. 5. Military versus civilian applications. The expectation that military applications will dominate the robotics challenge is challenged by the growing importance of civilian applications, particularly in industries like healthcare and manufacturing. This suggests that while military advancements are crucial, the civilian sector's innovations could have a broader impact on global technological leadership and economic stability, potentially overshadowing military capabilities. 6. Innovation ecosystems. The prevalent view that a fragmented ecosystem leads to more diverse innovations may overlook how a more unified and coordinated approach as practiced by China can lead to significant breakthroughs. China's ability to harness and direct its vast resources towards specific technological goals can create a more focused effort that yields rapid advancements, countering the narrative that diversity and fragmentation inherently yield better results. 7. Cultural perceptions of technology. The assumption that Western companies are more open to embracing new technologies could be countered by China's rapid adoption and integration of robotics into everyday business practices. This suggests that cultural perceptions about technology adoption may not align with actual capabilities or outcomes, challenging the stereotype of innovation as a Western-centric phenomenon. 8. Long-term strategic vision. The idea that short-term competitive strategies will prevail in the technology race might be misleading. China's long-term strategic vision, seen in initiatives like Made in China 2025, presents a focused approach that could yield sustainable competitive advantages over time, contrasting with the often reactive nature of U.S. technological strategy. In summary, the $10 billion robotics challenge between China and the USA reveals that the dynamics of technological leadership are complex and counterintuitive. The challenge fosters an environment where different approaches to innovation can coexist and the outcomes may not align with traditional expectations of superiority based on either state-led or private sector-driven strategies. The implications for global technological leadership, economic power, and the nature of competition are profound and continue to evolve as both nations pursue their respective paths in robotics development. The $10 billion robotics challenge between China and the USA is not just a race for technological supremacy, it represents a multifaceted struggle that encompasses economic, strategic, and geopolitical dimensions. While many people may focus on the high-level competition and immediate implications of this challenge, several crucial aspects are often overlooked which hold significant importance for the future landscape of global power dynamics. 1. Long-term implications for global supply chains. One of the most significant yet overlooked aspects of the robotics challenge is its potential to reshape global supply chains. The competition is not merely about who can build better robots but also about how these advancements can lead to more efficient production processes, logistics, and distribution networks. As both countries develop autonomous robotics for manufacturing, the implications for global supply chains could be profound. For instance, China's push for automation might allow it to dominate manufacturing sectors, thereby enabling it to control supply chains more effectively. Conversely, if the US can successfully integrate collaborative robots into its workforce, it could create a more agile and responsive manufacturing sector that could adapt to global market changes. This dynamic could lead to a realignment of economic power and influence, with countries aligning themselves based on their technological dependencies. 2. Military applications and national security. The military applications of robotics and AI are another critical area that deserves more attention. While the challenge is framed as a technological and economic competition, the military implications of advancements in robotics cannot be understated. Both the US and China are investing in robotics for defense purposes, with the potential to develop autonomous weapons systems and enhance logistical capabilities. This aspect raises ethical questions and concerns regarding the arms race in AI-driven military technology. The consequences of deploying autonomous systems in combat scenarios could lead to unintended escalations in conflicts and shift the balance of power in military engagements. The implications for international security norms and laws of warfare are significant, yet discussions around these topics tend to be overshadowed by the economic competition narrative. 3. Talent acquisition and human capital. Another critical factor that is often overlooked is the role of talent acquisition and human capital in this technological race. The challenge highlights the competition for skilled workers in robotics and AI, with both nations vying for the best minds in the field. The US's approach of fostering a public-private partnership may attract top talent from universities and tech firms, encouraging innovation through diverse collaboration. In contrast, China's centralized approach may streamline talent acquisition but could stifle individual creativity and innovation due to its restrictive environment. The long-term implications of these strategies on human capital development will be crucial in determining which nation can sustain its technological advancements beyond this challenge. 4. Impact on ethics and regulation. The rapid advancement of robotics raises critical ethical and regulatory questions that are often overlooked in discussions about technological competition. As both nations push the boundaries of robotics, issues related to privacy, job displacement, and the ethical use of AI-driven systems come to the forefront. The US, with its emphasis on public-private partnerships, may find itself grappling with the need for regulatory frameworks that can keep pace with technological advancements. In contrast, China's state-led approach could lead to quicker regulatory responses but may lack comprehensive ethical considerations. The manner in which both countries address these issues could set precedents that influence global norms and standards in technology governance. 5. Cultural and societal implications. The societal impact of robotics and AI advancement is another significant component that is frequently overlooked. In the US, the narrative around robotics often emphasizes collaboration and human augmentation, which could foster a more positive public perception of technology. On the other hand, China's focus on automation may lead to societal challenges, including job displacement and economic inequality. Understanding these cultural narratives is crucial, as they will influence public acceptance of robotics and AI technologies. The societal implications of this challenge extend beyond economic metrics and touch upon the relationship between technology and everyday life, shaping how citizens in both countries view the future of work and technology's role in society. 6. Global collaborations and diplomacy. Lastly, the challenge has significant implications for global collaborations and diplomacy. As both countries advance in robotics, their strategies could lead to a bifurcation of technological standards and practices. This division may strain existing international collaborations and create barriers for countries that wish to engage with both superpowers. For instance, countries may find themselves caught in the middle, needing to choose sides in a growing technological divide. This scenario could lead to increased tensions in international relations and a more polarized global landscape, where alignment with either the US or China becomes a strategic consideration for nations worldwide. Conclusion: the $10 billion robotics challenge between China and the USA is a critical turning point in the global technological landscape. While many discussions center around immediate competition and advancements, it is essential to consider the broader implications that extend to global supply chains, military applications, talent acquisition, ethics, societal impacts, and international diplomacy. These factors are not only significant in their own right but also interlinked, creating a complex web of influences that will shape the future of global technological leadership and power dynamics. Addressing these overlooked aspects is vital for understanding the full scope of this competition and its potential consequences for the world. 1. Technological arms race. The $10 billion robotics challenge signifies an intensified technological arms race between the USA and China. Each country is striving not just for competitive advantage but for global leadership in a critical industry that is poised to reshape economies and societies. This rivalry is not merely about robotics but encapsulates broader themes of innovation, economic strategy, and national security. The implications of the challenge extend beyond immediate technological advancements, potentially influencing global power dynamics and international relations. 2. Government support and investment strategies. A fundamental difference between the USA and China lies in their investment strategies and government support structures for technological development. The US approach emphasizes private sector innovation and public-private partnerships, promoting a collaborative environment that encourages creativity and individual initiative. In contrast, China's state-led model facilitates rapid implementation of technology through heavy government investment and centralized planning. This divergence not only affects the pace of innovation but also the nature of technological advancements that emerge from each country. 3. Diverse use cases and priorities. The robotics challenge highlights differing priorities between the two nations in terms of technological applications. The USA focuses on collaborative cobots that enhance human capabilities in factories, reflecting a vision of technology that complements human labor. Conversely, China emphasizes fully autonomous robots, particularly in logistics and manufacturing, showcasing a drive towards automation that may impact labor dynamics more significantly. Understanding these priorities is crucial for analyzing the potential social and economic consequences of advancements in robotics. For impact on global technological leadership, the outcome of the robotics challenge has the potential to redefine global technological leadership in profound ways. As both countries invest heavily in robotics, the winner of this challenge could set the standards for future technological developments, influencing global supply chains, international trade policies, and economic strategies. Moreover, the results could shape perceptions of innovation and competitiveness, potentially leading to a bifurcation in global technological standards based on the dominant approach of either the USA or China. This scenario could have lasting implications for countries around the world, affecting their own technological strategies and alliances. 1. The Space Race 1957 to 1975. The competition between the United States and the Soviet Union for supremacy in space exploration during the Cold War is one of the most famous historical cases of technological rivalry. Initiated by the Soviet launch of Sputnik in 1957, the space race spurred massive investments in aerospace technology, leading to significant advancements including human spaceflight, satellite technology, and ultimately the Apollo moon landings in 1969. This rivalry not only showcased technological prowess but also had profound implications for national security and international prestige. 2. The Cold War arms race 1947 to 1991. The ongoing military competition between the United States and the Soviet Union during the Cold War involved the development and stockpiling of nuclear weapons and delivery systems. Both nations engaged in a technological arms race with significant investments in ballistic missile technology, submarine warfare, and advanced radar systems. This period was marked by intense competition, espionage, and the constant threat of escalation, ultimately leading to shifts in global power dynamics and the eventual end of the Cold War. 3. The Internet Wars 1990s present. The competition for dominance in the digital and internet sectors, particularly between American tech giants and emerging Chinese companies, represents another significant technological rivalry. The rise of companies like Google, Apple, and Microsoft in the United States contrasted with the emergence of Alibaba, Tencent, and Huawei in China. This competition has implications for cybersecurity, data privacy, and global economic leadership as both nations seek to control the narrative and standards surrounding Internet governance, digital trade, and technology infrastructure, impacting global markets and geopolitical relationships. The $10 billion robotics challenge between China and the USA marks a significant point in the ongoing rivalry for technological supremacy, shaping not only the future of robotics but also broader economic and geopolitical dynamics. As we project into the future, several key trends and predictions can be identified. 1. Accelerated innovation and development. Both nations will likely continue to accelerate their investments in robotics driven by the challenge. The competition is expected to spur rapid advancements in AI and machine learning, leading to more sophisticated robots capable of performing complex tasks across various industries. By 2030, we may witness robots becoming integral to sectors such as healthcare, agriculture, and logistics, optimizing efficiency and productivity. 2. Diverging approaches to robotics. The differing strategies employed by the US and China will likely deepen. The US will continue to emphasize public-private partnerships, fostering an environment conducive to innovation through collaboration with universities and private firms. This may lead to breakthroughs in human-robot collaboration and personalized robotics solutions. In contrast, China's state-driven approach will probably yield rapid deployment of large-scale automation solutions, particularly in manufacturing and logistics, fostering efficiency through mass production and integration. 3. Global supply chains and economic power shift. The outcomes of this robotics challenge could reshape global supply chains. As both nations deploy advanced robotics, we may see a shift in manufacturing hubs, with countries that adopt these technologies swiftly gaining a competitive edge. By 2035, nations that lag in robotics adoption may find themselves at a significant disadvantage, leading to a redistribution of economic power. Countries like India and Vietnam, which are already emerging as manufacturing alternatives, may capitalize on this shift by investing in robotics to attract foreign investments. 4. Military applications and national security. As advancements in robotics evolve, military applications are poised to become a focal point of research and development. Both China and the USA are likely to invest heavily in autonomous weapons systems and unmanned vehicles, potentially altering the nature of warfare. By 2030, the integration of AI-driven robotics into military strategies could redefine defense postures, leading to new forms of warfare characterized by speed, precision, and reduced human casualties. 5. Ethical and regulatory frameworks. As robotics technology advances, ethical concerns surrounding AI and robotics will necessitate new regulatory frameworks. By 2025, discussions around the ethical implications of robotics, such as job displacement, privacy concerns, and decision-making autonomy, will intensify. It is likely that both nations will grapple with establishing standards and regulations to govern the development and deployment of robotic technologies, which could lead to international agreements or conflicts over technological governance. 6. International collaboration and tensions. The robotics challenge could also spur both collaboration and tension on the international stage. Countries may seek to collaborate on standards and ethical guidelines while simultaneously competing for technological leadership. By 2030, we may see the emergence of international coalitions focused on robotics development, which could either mitigate tensions or lead to further division, particularly as nations align with either the US or Chinese technological paradigms. 7. Impact on workforce and education. The rise of robotics will necessitate significant changes in the workforce and education systems. By 2035, there will likely be a pressing need for reskilling and upskilling initiatives to prepare workers for an economy increasingly dominated by automation. Educational institutions will need to adapt curricula to focus on STEM, science, technology, engineering, and mathematics, and interdisciplinary studies that incorporate AI and robotics, ensuring that the workforce can meet the demands of an evolving job market. 8. Influence on global technological standards. As the US and China vie for dominance, the challenge will likely influence global technological standards in robotics. By 2030, the country that establishes widely accepted standards for robotics and AI will have a significant advantage in exporting its technologies and influencing other nations' technological strategies. This could lead to a bifurcation of global standards, with nations forced to choose sides, impacting interoperability and collaboration. Conclusion. The $10 billion robotics challenge symbolizes a critical juncture in US-China relations and the global technological landscape. The implications of this competition will resonate far beyond robotics, influencing economic power dynamics, military strategies, ethical considerations, and international relations. As both nations continue to innovate and invest in robotics, the outcomes of this challenge will play a pivotal role in shaping the future of technology and global leadership. The world will be watching closely as these developments unfold, anticipating a new era defined by advanced robotics and AI.